Hi, my name is Barnaby Donoghue. I work here at Pico Technology, and today I'm going to take you through the guided test for CAN bus serial decoding, which means we're going to use PicoScope to measure some voltages on the CAN line and then use the PicoScope software to decode those so that we can see numbers instead of voltages. You might want to do this test if you want to look behind the scenes. Maybe you want to see what control units are on the network. Maybe you want to see if you can identify invalid messages, that type of thing. So the first thing is we'll go to PicoScope and we'll open the test. If we go to the automotive menu, communication networks, and then CAN serial decoding, click on that. And what we find is that PicoScope will bring up for you the test guidance, and then it will also, underneath that, it'll preset the screen ready for you to make a capture. Now you'll notice that there's something a bit different about this screen. It's in two halves effectively. On the top half, we've got an example waveform as per normal, and we've got, you can see there's two channels. Plus some other channels, or some other data, which I'll describe in a moment. Then below that, on the bottom half, we've got a table, and that is our serial decoding table. So what we can see is that PicoScope will take every message that it records, and each message will be given a row in the table. And from that table, we can inspect its properties. So its actual data, whether it's valid, its ID, and so on. So we've got PicoScope set up. Now what we need to do, and that's is connect everything up, and that's all connected via the USB port to our PicoScope scope. Now we connect our channels to the vehicle. So if we take channel A, connect that to channel A of the scope. I'll just leave the wire there for now. Now we'll take channel B, or which is our red wire, which we'll attach to the BNC connector on the scope. So those are our two probes, lay that there. Next thing is we'll connect the earth fly leads on our probes, on our test leads. We'll connect those to a good battery earth. Oh, that goes in there. And then we can connect channel A and channel B. So we're all connected up onto the vehicle. You'll see that I'm connected under the bonnet. We've actually got breakout leads going into the ABS control module here, because that's the only way we can access the powertrain control module on this vehicle. If you're lucky, on some vehicles you can do it at the diagnostic link connector or the OBD connector. Or you might have another network that you want to look at. And on that note, we'll see in PicoScope here, on the serial decoding, this decoding functionality assumes a specific baud rate. That's how many bits per second the bus actually communicates at. That's its communication rate. So most powertrain buses are around 500 kilobits per second, or 500 kilobaud. You may need to use another test, our other guided test for CAN bus networks, for high and low, to look at just the voltage of one frame. And if you do that, then you can see find the smallest data bit within that frame, work out the time that takes, inverse it, and that will give you what your rate is, your communication rate. That's already set up here, so as a first timer you should be all right to go with this. We see, yes, so we've got your baud rate. It's actually going to be looking at something called A minus B. So this is now the other data that you've got on your screen. It's going through, when you run the test, PicoScope goes through the data it captures, and then it looks at your channel A minus channel B. So that's the difference, the voltage difference between the CAN high on channel A and the voltage on CAN low on channel B. Now, when you do that, you find you get a nice stable signal, and that's what our serial decoding is using as its reference point. That's all set up. We're ready to go. Now if we select go, it's waiting for data, so we can turn on the ignition or start the vehicle as per your test. Okay, so we can see that this is capturing lots of nice chunks of data. We've got enough to be looking at there to start with. Let's turn off the vehicle. We can turn off the scope as well. We can see that the time base, or the length of time that we're acquiring for on every buffer on the waveform, so every screen full, we've got about 2 seconds per screen. So that gives us almost 500 CAN messages per screen. So that's a lot of activity on your powertrain CAN bus. Now, what's really nice about this serial decoding, it'll do two things. If you've got a bad message, it's invalid, then it will highlight it. It'll be red, so red highlighted. If it's good, it will be black. So if it's red highlighted, that's handy. But then the second really handy, or more handy thing, is that if you double click on that message, or any message, or that is the row within the table, you double click on any row, that will take you and zoom in your signal, so you can really look at the precise voltages that you've recorded within your trace. So that's great. So we can use the table to look at specific messages that might be highlighted to us, and we can look at the actual voltages. We're also able to use, there's a filter function on the table, so that's a bit more of an advanced feature. We'll discuss at another time, given that this is only an introductory getting started video. But we can filter messages and look at individual messages with individual identifiers, or we can look at groups of messages. So we've got all that type of functionality built into your serial decoding. Also, if we go back to PicoScope here and back to our guided test, we see that it sort of obviously describes the test, describes example waveform that you'll capture over the whole trace. And then at the end there's some further guidance, and that explains a bit more of the detail about the messages and CAN networks and how they operate in general. So this is a very introductory video just to get you started with a serial decoding on a CAN bus, and yeah, I hope that sees you on your way to start with. So thank you for joining us, and we'll see you next time.